Okay, good morning, everyone. It looks like everyone who's called in has successfully joined, so we will get going. Hopefully, nobody was up at 8 o'clock this morning and trying to join the meeting based on the announcement I posted yesterday. I actually inadvertently put in the times for my lecture tomorrow. So, if anybody did attempt to access the lecture at 8 a.m. This morning. I apologize for that. Could I just ask everybody to mute their microphones? We do have a couple of people who I'll start muting some of them. Okay. There, I think we have everyone muted now. Okay, so today, during last week's lecture, we did not get to the first lecture, which was environmental fieldwork. And there is homework that's associated with that lecture. I did notice that many of you have submitted that homework already. So I'm assuming that you read ahead in the NDC Connect. I took a breeze through some of them, and they're actually quite well done, considering that we haven't covered the material in class yet. So what I did last night, because I had not extended the due date for the homework for that lecture, I have extended it for an additional week. So anyone who hasn't submitted it can do so after this lecture. Anyone who has submitted it already, if you do want to take a quick look back at what you submitted, and if you feel that you want to change anything, then I will certainly allow you to resubmit. Okay, so I just wanted to quickly go over lab 1. Both groups have now completed lab 1. And I do have, especially from last Friday's group, I have the majority of the reports are in for that. Does anyone have any questions at this point in time regarding lab 1? So anything that we did out in the field, anything related to the report that needs to be submitted? If anyone has any questions, just throw them, put those questions in the chat and we will answer them. And it doesn't look like anyone has any questions. Okay, so what we will do now is I am going to share my screen and we will go through the environmental fieldwork module. So that's okay. So just as I start this this module, I do want to point out that the vast majority of you have done the environmental fieldwork safety quiz. There are a couple of people who have not done it at this point in time, and there's a couple of people who need to redo it. I have begun sending out emails to those people, but you do need to be aware that if the quiz is not done and you have not scored at least 80%, you will not be able to participate in tomorrow's lab or next Tuesday's lab. So I would appreciate it if you could get that quiz done or redone, whatever the case, as soon as you can. Okay, so this is the module on environmental field work. And the main topics of this is organizing and preparing equipment for field work, conducting field sampling, following published sampling protocols, calibrating, troubleshooting, and performing basic repairs to field equipment, ensuring sampling is conducted safely, and responding effectively to unexpected events or emergencies that may occur in the field. I think I mentioned this to you last week, that it's been my experience over the last 30 years that the further you are away from your office, the further you are away from help, the more likely it seems that something is going to go wrong. So organization and preparation for doing any type of field work is critical to ensure that when you do get out into the field, that things will hopefully go as smoothly as possible, and any issues will be minimized. Okay, so planning prior to setting out to conduct field work is essential. It's essential for several reasons. One of them is effective use of time and resources. When you get out to the field work, quite often, you have a lot of samples you have to take, and you have a finite amount of time in order to take that. Usually, the project manager knows how many samples can be collected, and within what kind of time frame. So you do need to be effective when you get out there to do the sampling, to make sure that you are effectively using your time and the resources that's available to you. And of course, safety while in the field. The planning process surrounding safety actually begins before you go to the field to do the actual sampling, and that's what Homework One is designed to give you a feel for. Usually there's some type of risk assessment that is done that will just run through the type of activities that you're going to undertake, and what some of the potential safety issues could develop around those activities, and what some of the mitigating factors are that can be put in place to ensure that the sampling event is undertaken safely. And of course, integrity of the sampling results. In the planning portion, before you go into the field, you should, in fact, you must know what type of samples you're going to be collecting. You have to ensure you have the appropriate containers, coolers to put the collected samples in if required. So through the planning process, you have to make sure that all of those things are in place before you go out into the field. And as this last statement says, while conducting field work, the unexpected can and will happen. It is important to be prepared, and remember, safety is the most important consideration. So safety is always tops. We do not try to shorten the time that we're in the field by taking shortcuts that can impact safety and result in an accident. Okay, so preparing equipment for field work, and this is something that is really critical. It's amazing how many times field technicians get out into the field and they get their equipment out and they go to start it up and it doesn't start, and it's usually because the technician or the technologist before them put the equipment back into storage with dead batteries. Right, so it really is important that you prepare the equipment ahead of time before you go out to do the field work. Right, so use checklists when packing and preparing equipment for field work. Checklists are something that we use extensively. For every type of project we do, we have a checklist, and that checklist says that you need to have this piece of equipment, this piece of equipment, and this piece of equipment. May not be so important if the only piece of equipment you're taking out to the field is a pH meter. But if you're doing something like stack source testing, you can have virtually hundreds of pieces of equipment, and you need to have some type of checklist that as those pieces of equipment are packed either into shipping containers or into the vehicle, they get checked off the checklist. Right, so when packing equipment for field work, consider the method of travel. There are multiple methods in which you get to the actual sampling site. You may have to catch a plane to fly to a remote northern location. You can be using a van, pickup truck, or a car. When you get to your sampling location, you can be using a canoe, a boat, or in some cases, cranes must be used, especially if you're doing stack source testing. Okay, and also consider the distance from the vehicle to the field location. There's nothing worse than getting to the field, find out that your actual sample location is about 400 meters from where you can park your vehicle, and you have to get all these boxes to that sampling location. So, you need to give some consideration to how are you going to pack the material to get it to the sampling location as efficiently as possible. Okay, consider the use of toolboxes to organize and transport equipment to the field and protect equipment from breakage during transport. Toolboxes are a critical piece of equipment. A lot of the equipment that we use does have some sensitivity associated with it, so it needs to be protected at all times, especially during transport. You don't want to be taking these pieces of equipment loose outside of storage cases and just throwing them in the back of a vehicle. They need to be transported as safely as possible to avoid damage to the equipment. After sampling, the equipment must be cleaned, note any need for maintenance, and return it to its proper location. So if you're in the field, you have a piece of equipment. Most pieces of equipment have a battery indicator signal on them that will indicate when the batteries are getting close to needing to be changed. You certainly, if you're taking a piece of equipment back and that indicator light has been on, want to make sure that when you return it to storage, that you replace the batteries in it, just in case the person before you grabs it and leaves without checking. But then, of course, you should always bring a supply of batteries and spare parts. Many of the pieces of equipment that we use are very hard on batteries, so they go through batteries in a very short period of time. So whatever equipment you have that is battery operated, you need to ensure that you have spare batteries to put into the equipment in the field should those batteries die on you. Ensuring the staff is adequately trained. That is usually the role of the project manager. He will make sure that the staff is adequately trained in the sampling methods that will be used while they're out in the field, and the procedure to follow if problems are encountered. And usually the procedures to follow are essentially procedures that will result in a quick fix in the field. But usually the last part of the procedure is, if all else fails, call the office to get assistance from the office. Most of the pieces of equipment that you use will have some instructions with them, and those instructions usually include troubleshooting to resolve the common problems that go out that can occur with that equipment. But that is where the training comes in, is that before you go into the field, you have to be comfortable that you're adequately trained in the use of that particular piece of equipment, that when you get there, you know how to use it and you know how to overcome any minor issues that happen with that equipment. So this is an example of a typical checklist that would be used when conducting field work. So if one of your tasks was to collect samples and measure the pH, you would have a checklist that says you need a pH meter, pH manual, pH buffers, liquid waste bottles, spare batteries. And in this checklist, it does actually ask for you to write down the status of the batteries before you leave your place of employment, the electrode status, and the date of the last 3-point calibration. So that's a fairly typical, simple checklist that can be used for a pH meter if you have to take a pH meter into the field to conduct field pH measurements. So these checklists are extensively used in industry. They vary from company to company, but essentially they all contain the same information. Safety equipment is specific to the type of field work, but might include sunscreen and bug spray. Definitely, if you're working outdoors on any project, sunscreen and bug spray is a must. First aid kit. You should always have some form of a first aid kit with you to deal with minor injuries that might occur. If you are provided with a company vehicle to get to the field sampling site, I will say that most, if not all, company-owned vehicles would contain a first aid kit. But if you're using your own private vehicle to get there, it's important that you ensure that somewhere in your equipment or vehicle is a first aid kit. Satellite cell phone. Satellite cell phones are used in areas where it is known that there will be no cell phone signal, and satellite cell phones are usually provided by the company that you work for. Not many people have satellite cell phones that they use in the private life. A fall arrest harness, if you are working at heights, so if you're working at a height greater than 5 feet above grade, you will generally have a fall arrest harness on that will stop you from falling off of scaffolding or off of a rooftop or off of a stack. Life jackets and life ring. If you're working around water and the water is of significant depth, you would definitely wear a life jacket and have a life ring available to assist anyone that happens to end up in the water. Work boots are standard. Work safety boots are standard on any work site, so they are a must. You should not be doing field work in running shoes. Reflective vests. It is now the policy of most companies, and even in industrial companies, when visitors enter plants, that you will wear reflective vests. These are just a bright orange reflective vests. They usually have a cross on the back and stripes down the front that will reflect if light hits them, and it just adds visibility to you as you're working in the field. And these are especially critical if you're working around heavy equipment, so drill rigs, large excavators, dump trucks. The reflective vest is an important piece of safety equipment because it just improves your visibility to the operators of those pieces of equipment. And of course, respirators, coveralls, and gloves if required. Okay. Field work is generally conducted out of reach of head office, and field staff must be prepared to work independently and make decisions on their own using the best judgment. And that was something that I mentioned last week, that field technicians and technologists who become known to be able to work independently and have excellent troubleshooting skills, they tend to be the ones that get the interesting projects in remote locations, because the project manager has some faith in you that you will be able to go there and overcome any minor difficulties that you may encounter. As it notes, independently does not mean working alone. Field work should always be conducted in pairs or larger teams. So there should always be two people present when you're doing field work. And making decisions, consider, is it safe? That's the primary decision that you have to make, is it safe, whatever you're going to do, and will it impact the integrity or validity of the results? If at any point in time you have to digress from the sampling plan that's been provided for that site, you have to make a decision as, will that digression impact the integrity or the validity of the results? And an example of this is, if you are in the field and you're working with a drill rig to install boreholes, the project manager has identified 4 or 5 locations where a borehole will be placed. You get to the site, the drill rig operator tells you he cannot drill in that location, you need to move locations. So at that point in time, you have to consider, will that move impact the integrity and validity of the results? And in most cases, with most companies, the process in a situation like that is to call the project manager and get his approval to make that change before it's made. Sampling should always be stopped if it isn't safe or if the validity of the results will be impacted. So coming back to the drill rig, installing boreholes, if the borehole has been planned for a certain location, you get there, the drill rig operator says, I don't want to drill this hole because I'm only 5 feet away from a high power electrical line, then the sampling must be stopped in that area. Right, so that would be a definite safety hazard, and you would not want to override the drill rig operator and instruct him to then drill that borehole. Okay, before conducting field work, review sampling protocols and plan how the field work is to be conducted. Most of the sampling that we do is done under some sampling protocol. The one that's shown as an example in this slide is one from the Canadian Council for Ministers of the Environment, and it's protocols for protocol manual for water quality sampling. There are numerous various sampling protocols out there. Most consulting companies have their own in-house protocols that must be followed. So it's important to ensure that you're trained in whatever the appropriate protocol is prior to conducting the field work. So before you leave the office, you need to be sure and you need to be comfortable that you're trained in the application of that protocol. Bring paper or electronic copies of the protocols to the field in case they are needed for reference. Some of the sampling methodology out in the field is actually quite complex, so it is very helpful to have the actual protocols available to you. So where possible, you should bring the sampling protocol or the company's protocol manual with you into the field so you can refer back to it. Of course, bring instructions for any equipment that is to be used. Sometimes you'll use a piece of equipment and you will use that piece of equipment several times a week, and you'll become very comfortable with it. And you will get to the point where you feel you don't need the instruction manual, but you should always have instruction manuals available. If an issue develops with that equipment, usually there's a troubleshooting section, and that will help you work through those issues. And seek clarification before heading out to conduct the field work. If there's any questions that you have prior to heading out, before you leave is the time to get those questions answered. You want to have them answered. You want to ask them and have them answered and be comfortable that you understand the answer before you leave for the field. If you end up in the field without all the necessary equipment or encounter another problem, have a backup plan so that all the field time in the field isn't wasted. And this can be very difficult, because if you've forgotten a key piece of equipment, you know, a backup plan may be difficult to implement, but potentially, you know, as a last resort, your backup plan is that you need to go back to the office and get the piece of equipment, or have it delivered to you at the site. But it's important that not all of the field time is wasted. Your boss will not be happy that you forgot a key piece of equipment, but he will be even more unhappy if the whole day in the field is wasted because there was no efficient backup plan. So, you know, and this comes with experience. You tend to, as you get experience sampling in the field, you tend to be able to develop backup plans for many of the issues that you will encounter. All right, calibrating field equipment. Field equipment requires calibration every time it is transported before heading out to the field. All right, so you have to familiarize yourself with the operation and calibration of the field equipment. Ensure the equipment is in good working order. Ensure that all the supplies needed for the field equipment are available. All right, so in the example on the side is a conductivity meter. It has the 2 packs of conductivity standards that you can use in the field to calibrate that piece of equipment. So, but it's the most important part is that you understand the operation and and how to calibrate that equipment when you're out in the field, and also to be able to understand when the equipment is not working properly. It is, I probably shouldn't say often, but it does occur where you get out in the field and a piece of equipment begins to malfunction, and the readings that you're getting from that equipment are not accurate. So it's important to understand the equipment and to be able to recognize when a piece of equipment is potentially malfunctioning. And that is part of the reason why calibration is so important, because if you believe an instrument is malfunctioning, you can calibrate it right there and then to ensure that the readouts that the equipment is giving you is in fact accurate. Okay, maintaining field equipment. It is the technician's responsibility to maintain the sampling equipment, keep equipment clean and dry, remove batteries from equipment that is used infrequently. If you Do not remove batteries from a piece of equipment that's maybe used only once a year. You take that piece of equipment out, it doesn't work. You open the battery compartment, and what you find is a whole bunch of salts because the batteries have corroded. Maintain electrodes following manufacturer's recommendations. In the case of pH, you have to keep the electrodes moist. To regenerate pH electrodes, you need potassium iodine. Using hot soapy water to remove dirt blocking temperature sensors, protect bulb from breakage. For dissolved oxygen probes, disassemble probe and add electrode solution when needed. In some cases, removing rust using steel wool. This is a very common one when you're using groundwater elevation tapes. Those are the tapes that are on the red drums that you drop down into a monitoring well to get a reading how far down the groundwater is. It is common for the sensors on those tapes to get a little bit of rust buildup. So steel wool is usually used to remove that, and that usually resolves that issue. And refer to equipment manuals for additional routine maintenance requirements and troubleshooting. Conducting field work safely, always use common sense. Seems like that's something that really doesn't need to be said, but it is quite surprising how many times I see things happen in the field where the people doing it, they just are not using basic common sense, right? You have to plan to work safely. You have to adhere to any legislation. So any legislation in the Occupational Health and Safety Act surrounding working at heights or confined space entry, you have to ensure that you are adhering to those pieces of legislation. And there are others, not just working at heights and confined space. You need to reduce risks. So, water, around water, you have to be aware of water safety, proper footwear, skin protection, harnesses, respiratory protection, hard hats. Anytime you're working around equipment or in a construction area, you will be wearing hard hats. First aid training and first aid kits. Usually when you're working with especially with consulting companies, you will be provided with basic first aid training. And it's, as I mentioned earlier, it's important that you have first aid kits available. And communication. Got to be aware that cell phones often don't work in remote areas. Cell phones often don't work in areas that you wouldn't really consider remote. Several of the students during the lab last week had issues with their cell phones working in the woods just behind the college. So you need to be aware when you go into the field that many times your cell phone might not be working. Conduct a job safety and environmental analysis prior to conducting any field work. Also referred to as a pre-task safety plan or other similar names. And pre-task is just what it means. It's the pre-task safety plan is prepared and went through prior to going into the field. Okay, so to reduce the risk to the environment and their employees, many companies have a process that must be completed prior to conducting environmental field work. The next two slides show an example of forms that employees of the environmental firm Golder complete prior to conducting an environmental sampling or remediation. Note that all staff on site must sign the form. Okay, so this is a job safety and environmental analysis. This one is specific to Golder. Every environmental consultant has a variation of this, but in this case, there's the three-step process. First one is to stop. So to stop and assess, and you will go, when you stop to assess, you go through each one of these items and you mark them if yes, it's been addressed, or if it's not applicable. So if we just look at under planning, the third one down, require permits to work issued, right? So if a job task that requires a work permit, and an example of that could be if there is welding to be done as part of the project, a hot work permit will be issued. In this case, yes, would be marked. But if the field work you're going to do does not require any permits, then you would mark not applicable. preparation, employees fit for duty and not showing signs of fatigue. So, before the field work is done, that would need to be checked off. So go through the tasks and the stop portion, then on to the think portion, discuss the task in the work environment. So these points are generally discussed prior to conducting the field work. So weather conditions, site conditions, daily tasks that are going to be undertaken, equipment, materials, and logistics issues, interfacing work, simultaneous operations. You have to keep in mind that job safety and environmental analysis can be done for large remediation projects that are occurring over many months, or it can be done for small projects, a phase 2 site investigation that is only going to take a couple of days. So the discussion of the tasks involved will vary depending on what type of project that you're going to be working on. And are there then the third step, identify, are any fatal risk controls present? So working around heavy mobile equipment is definitely a fatal risk, right? So you have to have controls in place to prevent employees or even members of the public who happen to manage to get close enough to the equipment are protected from the equipment. So be visible and identify your safe spot. So be visible by wearing a reflective vest and identify a safe spot. Usually there is a spot that is set up for people who are not operating the equipment to be in, so the operator knows where you will be. And do not enter the zone of influence of mobile equipment until you have positive okay. So if you have to move out of the safe spot in order to maybe collect a sample, it's imperative that you make eye contact with the operator of the equipment, make sure that he sees you and that he's acknowledged that you're going to be moving into his zone of influence. All right, so we just go through each one of these. We mark them yes, or if it's applicable, we mark it yes, and we discuss all of the components of that, right? This next page. So this is very similar to the homework that you guys are assigned to do for this segment. But in the first column, you list any hazards, right? So any hazards that's not already identified in the job safety environmental analysis, right? You would list them here, and then in the column beside them, you would identify what the risk control measures are. And below that, everyone who was participating in the field work would print their name, and then they would sign to state that they have gone through the safety analysis. So this is a fairly as I say, standard. They vary from company to company, but it's a fairly standard form to fill in when you're heading out to the field to do field work. And we'll come back and we'll once we're through this module, we'll come back and we'll discuss it a little bit in more detail, more specific to the homework that you were assigned. Okay. Expect the unexpected. Many things can impact field work. These include weather, safety, security, and access, equipment failure, changes to the sampling plan, coordination of sampling with production or other work. Exercise good judgment in responding to the unexpected. Is it safe to continue? So if you have varied from your sampling plan, is it safe to continue with the new approach? Will this affect the sampling results? And importantly, do I have the authority to make a decision? In many cases, very experienced field staff have the authority to make an on-site decision to maybe move a sampling location to a safer location. But for junior staff, usually you do not have the authority to make that type of decision. And if something comes up where a change has to be made that will could potentially affect the sampling results, you essentially have to call your project manager back at the office, discuss the change, and get his authority to do that, right? So here's a list of examples of unexpected events, and I went through this list last night, and I think every one of these has happened to me in all the years I've been conducting field work. But delays in receipt of sampling containers and supplies is a very common one. Usually sampling containers are ordered from the laboratory to arrive at the site within a few days of the sampling actually occurring. And quite often we can get delays in that process. Witnessing a fight between employees. I've actually had to break up several fights between employees while carrying out field work. Equipment being stolen and tampered with. This happens more frequently than it really should if you have to leave equipment at the site, or if you're staying in a hotel, equipment being stolen from your vehicles. Airlines losing luggages containing sampling, production shutdown due to cold weather, wind blowing scaffolding down, injury to a co-worker, release of toxic gas. As I say, all of these have occurred with me. This one, items lost down sampling wells. It is, it would actually surprise you how often this happens, how often items get lost down sampling wells. And really, when you're working around sampling wells, it's important that you do not have any loose pieces of equipment or articles on your body that could potentially fall out and go down the sampling well. Depending on the item that falls into a sampling well, it could invalidate the results from that sampling event and any other sampling events down the road, unless that sampling or unless that item can be retrieved. And there is ways to retrieve many of the items that that fall down sampling wells. So when you're out in the field and it happens to you for the first time that something falls down a sampling well, call your project manager right away and see if you can walk through a process of getting that item out and how it's going to impact the sampling. Okay, so that is that module. Okay. I'm just looking. Okay, so Matthew said, where can we find the protocol for tomorrow's lab? We're going to discuss that. It's actually in DC Connect. I will let you know that I have been late getting a couple of these items into DC Connect. This is my first semester of working with DC Connect, so there's been some issues that have had to be resolved with getting this material into DC Connect. But it is all there. It is all there in DC Connect now, and we'll go through that once we've taken a quick look at the homework. Okay, so let's see if we can go to the homework section. Just give me one moment. And just give me one moment. I'll get this open. Okay, so this was the homework that goes along with the environmental fieldwork module. Like I said, I did notice a lot of you have submitted this already, but some of you haven't. The ones who have submitted it already, as I said, if you want to take a look at it and then resubmit, that's fine by me. I did, like I said, I did take a look at it, and for the most part, they were actually quite well done. But essentially, you were to choose one of these activities. Okay, so you can choose fuel tank removal and remediation of petroleum impacted soil, test pit excavation and soil sample collection, sampling of a creek, sampling of 20 unlabeled 45-gallon drums, or annual stack sampling at an incinerator. So selecting one of these as the field work activity that you're going to be undertaking, you're then going to move ahead and you're going to submit, or you're going to complete this task and hazard identification form. So if you were to select fuel tank removal and remediation of petroleum impacted soil, one of the activities and the tasks there would be, excavation using heavy equipment. Potential hazards would be struck by the excavator, contact with the excavation equipment with underground utilities, and what are the hazard control measures. So if your potential hazard is being struck by heavy equipment, your hazard control measures would be to wear reflective vests to improve visibility. It would be to remain in a safe spot while equipment is in operation, and making contact with equipment operators prior to moving into the area of influence of the equipment. So those would be hazard control measures that would prevent you being impacted by the potential hazard of being struck by the equipment. For potential hazard, the potential to contact underground utilities, the hazard control measure for that would be conduct public and private utility locates prior to conducting the field work. So it's important to note that in Ontario, it is the law that before you do any type of excavation or bore or install any boreholes, that at least a public utility locate be done to identify what buried utilities are in the area. And most private companies will then move ahead and do a private locate, where they retain a private locator to come onto the site and locate whatever utilities may be on the site and was excluded by the public utility locating company. So essentially, that was the homework, was to select the type of field work and then to identify 5 tasks, the potential hazards associated with those tasks, and what the hazard control measures are. I did notice that some people leaned quite heavily on what the environmental hazards would be with those tasks, and that's fine too. But these forms are usually prepared ahead of going out into the site to deal with potential safety hazards to field personnel. So that is the homework. As I say, I've extended that to September 20th, I believe it is. And Aaron just made the comment that he used to do underground utility locates, and it's shocking how many homeowners don't call before digging. And well, Aaron said it's shocking how many homeowners don't call before digging. It's actually quite shocking how many companies will do an excavation and will not call for utility locates before they actually do the work. We had an instance in our neighborhood where somebody was installing a fence. the construction company that was doing the fence had called for utility locates about 10 days ahead of the work being done. They got there, they hadn't been, locates hadn't been done yet. The law says at that point in time they shouldn't have started work, but they were confident there was no utilities in the area where they were going to be installing the fence posts. So they decided to proceed, and on the third post, they went right through the gas line running to the house. So it created a major issue, and that company does face significant fines. It's amazing how, when you do not get utility locates before doing any type of digging, how you will put one small hole which just so happens to be directly on top of a small gas line. So it really is something that's critical. We'll see. Okay, so there are modules available on DC Connect for the lab, but we can't click on them. They appear locked. Same issue as Matt, same issue. So seems like everyone has the same issue. So I'm just going to go take a look at DC Connect. There are some modules in there. Can somebody maybe put in the chat what an example of one of those modules is? Okay, for tomorrow, Terra Stream assessment protocol. Okay, so when you click on that, look in your downloads. Look in your downloads for your internet browser. And if you look in your downloads, you should see that particular document downloaded. Will, can you do that? Can you look in your browser download page and see, did it download? Okay, it sounds like it doesn't let you click on anything. Okay, it is 2 minutes to 10. Let's take a 10-minute break. You guys take a break, and in that time period, let me go take a look and see if I can figure out what might be going on with it. Okay. All right. So let's be back at 10:10. Okay. All right. Thanks, guys. Okay, it's 10 after, so let's get going again. So what I'd like to do uh, before we go any further is I would like to share my screen for the DC Connect. We just have to. Then of course this. Just bear with me for one moment. Okay, you should all be able to see my screen. So here is the stream assessment protocol pre-lab quiz. There are no marks associated with these quizzes, but if you can get them done, it should help you when you get out there, right? But here are the documents, right? S1M3 site identification. Click on it. It opens up. This is the form that you're going to need to fill out in the field tomorrow. So could somebody indicate to me if you're not able to open these documents that I'm opening? The site identification form, a completed sample. The site features field form. So as okay, so is this an issue that you just cannot click on them? Okay, so what I will do is as soon as this lab is over, I will start emailing these documents to you until I can resolve with Durham College as to why you're not able to click on any of these documents. So I will resolve that. For now, we will just we will work through on my screen what these documents are. So for lab one, as I'd indicated to you guys that during your last lab, we have to identify a site that we're going to use. We have to identify a site that we're going to use for the following 3 weeks to complete, the water sampling, the Bethnic sampling. So we are going to go out into the field. Can one of you guys indicate to me in your environmental sampling lab with Dimitri, are you guys split up into lab groups for that? For his lab? Anyone? Groups or pairs? Are you split with Dimitri? Are you split up into groups or pairs already? Not currently, no. Okay, all right. So, what we need to do? I believe there's 12 of us in the lab group for tomorrow. So, we need to assemble ourselves into 4 groups of 3. Okay, when we go out there tomorrow, we're going to follow the Ontario Stream Protocol. And we're going to use this, that we're going to fill out this site identification form. It's important that I get you guys access to the Ontario. Okay, so I have just went back a screen. Can you guys see these documents? Are these not hyperlinked either? Okay, so you can see on my screen that the Ontario Stream Assessment Protocol just popped up. Can any of you guys access this? Okay, all right. So it looks like for some reason none of these are hyperlinked to get to them. But this this link that I just clicked on takes you to the actual Ontario Stream Assessment Protocol. Right now I'm on page 1 of 546. I don't think it'll be much of a challenge for you guys to read all 546 pages until or before we get to the stream tomorrow. But what I would say about these type of documents is I don't think I've ever sat down and had to read all 546 pages of a document like this. You essentially target the sections of the document that apply to what you're going to be doing. So when you get this link, if you go on to page 63, it gives you an example of how to complete your site identification form, right? In this particular example, they use Wilmot Creek and they have a stream code and a site code. When I get you access to the lab, you're going to see that in the lab, you're going to be given the stream name, the site code, the stream code, site code, and all the information that you will need to put in the form in these areas, right? You're going to input this UTM coordinates, okay? In this example that they give us in the document, they have the uncorrected UTM coordinates and the corrected UTM coordinates. You will only be using the uncorrected because you will not be able to correct the GPS coordinates that you get from your phone or GPS unit in the field. So we're just going to have the uncorrected UTM coordinates. So we're going to use UTM. We're not going to use latitude and longitude. So you can see the way that these forms are filled in, right? Is that where we have the uncorrected UTM coordinates, we have all of the boxes completed. Over on latitude and longitude, we just have dashes through them. So any boxes that are not completed in the field, simply get a dash put through them. Okay, you indicate how you got your GPS coordinates. You indicate how you accessed the sampling area. In this example, let's take Highway 115 north to 4th Concession Road, turn west. Your one would say something like, you know, go to Durham College, proceed to pathway at, you know, west side of Durham College, you know, take pathway down to Creek, go north, however many meters, right? So it's important that this access route gets completed and gets completed fairly accurately. And the reason why these sections need to be completed accurately is because theoretically these sites are set up, and then every year somebody goes back to those sites to conduct the sampling on an annual basis. So they always want to make sure that they are actually going back to the same site, right? So describe your site, you know, where your site is. You will do, below that, you will do 2 sketches. You will do a sketch of how you actually access the site, okay? And a sketch of the actual site itself, okay? You're going to take 2 photographs, right? You're going to tell us what the photograph number is. maybe photograph 1, photograph 2, but what the name is, right? So US, looking upstream, 18. They've also called this one US, but looking DS, downstream, and a description of what that, a more detailed description of what that photograph is. So the first one was upstream, crossover, looking upstream. So I went through with you guys last week what a crossover is. Ideally, the site that you select will have a crossover at the top of the site. It'll have a crossover at the bottom of the site. And you can see in this site sketch that they've marked the top crossover, the second, and the bottom crossover. And they've given some measurements or some markers which can be used for somebody else to actually confirm they're at the right site. Okay, there is a box up here that says site was unsampled. We're certainly not going to click put anything in here, because if we mark that the site was unsampled, your 4 labs would come to an end right there. So we're not going to mark that the site was unsampled. At the bottom, we're going to put any comments. In this example, high algal growth throughout the stream, beaten trail and discarded fishing line. So just any type of observations that you see. If you see high algae growth, you would mark it. If you see areas of severe erosion, you would mark that. At the very bottom, crew leader, initial and last name. So initial here, last name, and crew initials. Okay, so whoever else was in your group, initials go here. Who recorded the form, entered, verified, and corrected. These, the only one here that should be filled in would be the entered, and potentially the verified if you're the other members of your group verified that these sketches are correct. But the corrected one would not be filled in, because you should not be making any corrections. So here are the site marker details. An upstream marker, where it is, the distance, downstream marker, same thing, and then description of what these markers are. Okay, and that is essentially all we're going to have in the site identification form for tomorrow. If you scroll back up, go back a couple of pages, I believe it is, it will give you table 1 guidelines for filling out the site identification form, right? So data required for the stream name section, record as shown in the master stream name database. In your case, you will record as shown in the lab documentation. Date, you'll record the date as year/month/day. So it is important, because we're following a protocol that we follow any instructions that are given to us for filling out the form. So when I get the forms back, I need to see the date as year, month, and day. For your uncorrected UTM coordinates, you record at least the following number of digits for the coordinates. For grid, it will be 2, which will be 17. Your easting will be 6 digits, and your northern will be 7 digits. So just take what I would do if I was you guys is I would print this table and bring it with you tomorrow, along with the completed example form and a copy of the form that you're going to fill in. So I would have all 3 of them with you tomorrow. Okay, so once we fill out the site site form, we then fill out what's called a site features form. And on the site features form, we will see, right, there's examples for filling out the site features form. This one is on page 67 of the PDF document, but it goes through evidence categories for site features identified at the sampling site. So evidence category, ongoing and active, there is evidence of the feature at the time of the visit. So if you are going to put in on yours that there's heavy fishing activity taking place, one would be ongoing and active because you actually saw evidence of it at the time of the visit. Historical evidence, there are signs that the activity has occurred in the past. That could potentially be if you're seeing pathways to the creek and you're seeing discarded fishing equipment in the area. There is evidence that that has taken place historically. So these tables just give you information on how to fill out the form in the proper way of filling it out. So on this form, we need the stream code from your lab document, your site code from the lab document, and the date, your month and day. And then we're going to go through each one of these. And if you look at this, in this example here, point, potential point or non-point source of contaminant. In this example, they have marked no evidence with an X. And then the other boxes that have not been used, you draw a line through each one of these boxes. Okay. The next one down, major nutrient source. You can see that they've marked ongoing and active, and they've put a line through the boxes that have not been used. And then the comments, in this case, it's the Village of Orono septic bed leachate. So major nutrient sources upstream. It's unlikely that you will see any from where you will be tomorrow, but just keep in mind that an X through the one box that's applicable and a line through any boxes that are not used. Okay, charnel hardening or straightening. Again, if you go back up into the tables above, you will see examples of what these refer to. So channel hardening or straightening. Hardening is indicated by riprap or gabion baskets. Straightened channels will often have dredged materials piled adjacent to the stream or will be atypically straight relative to the valley gradient, right? I'm not sure if you guys are familiar with riprap. It's essentially the bank is covered with large stone. And those large stones act as erosion control, or it could be gabion baskets. Sometimes you will see gabion baskets piled on top of each other. I would go, if you're not sure what gabion baskets are, I would Google that. But essentially, they're baskets, they're wire baskets that are about 4 feet by 4 feet by 4 feet. They're filled with large stone, and they're placed into the creek to minimize bank erosion. So in your channel when you get to your channel hardening or straightening section of your form, you will look for any of the evidence that's indicated in these diagnostic indicators. So as I said, I will email these to you so that I can be sure that you have them. If you could print them out before you come to the lab so that you have them with you, because we don't have a lot of time at the lab. And essentially this lab is set up so that you guys so it appears that Aaron has figured out what the issue was. Yeah, I'll take a look at that as soon as I'm off this call, because as Aaron says, it looks like potentially I've got it locked until tomorrow, which they definitely should not be. So I will actually print some of these and bring some with us for tomorrow as well. But if you could go through the Ontario Stream Assessment Protocol for these two sections that we're going to be doing tomorrow, which is the site identification and the site features, so that you're aware of what we need to do. This document is used by pretty well every conservation authority in Ontario to do their stream assessments, and it's used by all the conservation authority so that there's standardization across all of their assessments. So this lab will give you some good practice of using an actual protocol to do this sampling. And hopefully hopefully I'll get this straightened out once we're off, and you guys will have access to it uh, by this afternoon. And like I say, I will print some off. I started to say that this lab is set up to give you guys practice at doing these forms in the field as efficiently as possible. So it's actually set up that the completed forms and the 2 photographs have to be submitted by the end of day Friday. Okay, so we need to do our best to get out there, get through this, select the site, complete the forms, and get them submitted back to me. Okay, so I apologize for the issues surrounding accessing these documents, but I will straighten it out as soon as I get off this call. Okay, so we are now going to move on to the next module of the topics course, and that is Unit 2, Phase 1, Environmental Site Assessments. I'm not sure if you guys have done any work previously on phase ones. You may have just discussed them briefly in class, but for the next 2 or 3 weeks, we're going to go through these in finer detail. So I will just again attempt to share my screen. Okay, so I just started sharing Unit 2, Phase 1 Environmental Site Assessments. Okay, the learning outcomes from this unit will be, after completing this module, you should be able to demonstrate your ability to do the following: prepare components of a Phase 1 environmental site assessment, identify, select, and use scientific concepts and models in the prevention, control, and elimination of environmental hazards, and in the remediation of contaminated sites. And these learning outcomes are all tied back to the program standards. So in the program standards, there is listed a series of learning outcomes that we as professors should have taught you on and got you to the position where you're comfortable in actually completing these tasks. And at the end of 3 years, you've done all the learning outcomes and you get your diploma. So these are the 2 learning outcomes that are associated with the Phase 1 module of this course. Okay, so in the introduction, we're going to go do an overview of Phase 1 environmental site assessments. We're going to look at lessons from history. We'll be looking quite extensively at Ontario Regulation 15304, records of site condition. We're going to look at some of the purposes of a Phase 1, common sources of contamination, likelihood of finding contamination, qualified persons. We're going to look at the process for conducting a Phase 1 ESA, which is essentially the records review component, the interviews, the site reconnaissance, the review and evaluation of information, and then we're going to look at report preparation. Okay, so when we come to an overview, historic use of properties for industrial activities has resulted in soil and water contamination. To safely redevelop these industrial properties for residential use, it is necessary to remove any hazardous contaminants. Ontario, there is legislation that requires an environmental site assessment to be conducted, and if necessary, remediation prior to allowing a change in land use to a more sensitive land use. So the requirement under the legislation in Ontario really gets triggered when there's a piece of property that's been used for industrial or commercial land use historically, and a developer comes along and he purchases that property and submits an application to the local municipality to build either single-family dwellings or multi-unit condominiums or apartments. So that change of land use triggers the requirement to conduct a Phase 1 environmental site assessment under our legislation. And these photographs at the bottom give a bit of an example of this. This is at 1805 Simcoe Street North, Oshawa. Pre-construction, you can see how, you know, just these there was probably some type of small business or at this site. It was purchased by a developer. The site was redeveloped, and now we have residential units sitting on that property. So for this site, 1805 Simcoe Street North, because there was a change of use, they would have been required under Regulation 153.04 to conduct a phase 1 environmental site assessment. And as we'll see, in many cases, those phase 1 environmental site assessments make a recommendation to carry out a phase 2 in order to confirm or refute the presence of contamination at the site. Okay, so lessons from history. This is a site, Love Canal in New York, that occurred back in the 1970s. So essentially, between 1974 and 1978, 56% of the children in the Love Canal neighborhood were born with a birth defect. Okay, the cause was determined to be the mother's exposure to pollutants, for example, benzene, that were from the hazardous chemical disposal sites upon which the residential subdivision was built. Just for interest's sake, have you just maybe indicate in the chat if you any of you guys have actually heard of Love Canal, and if you've done any background reading into Love Canal. So maybe just a couple of you just throw a yes into the chat. Yes, anyone here of Love Canal, or a no if no one's? Yep. Okay, so Aaron's heard of it. You know, it was. Okay, so Will says that he hasn't heard of it. You know, when I was coming through the environmental program, this was an issue that was still front page news. You know, once the issue was discovered, it went on for many years. And there are some links in DC Connect to some of the YouTube videos and some of the documentaries on Love Canal. And I would encourage you, I mean, especially if you haven't heard of Love Canal, to maybe look at some of those documentaries and some of those YouTube videos to get a better understanding of what happened there. But the land, essentially, the land had previously been used by Hooker Chemical Corporation, the United States Army, and the city of Niagara Falls as a municipal and chemical waste disposal site. The site was filled and covered with dirt in 1953. With the contamination forgotten, a residential subdivision was built on the site. So the photograph to the right is a photograph that was taken during some of the excavations that took place at Love Canal. And you can see the houses built on both sides, of which is a very obvious rectangular piece of property. That obvious rectangular piece of property was the area that was excavated many years prior to build a canal. And the canal was supposed to move water from the Niagara River through some generators to generate electricity, but the project was abandoned, and the canal became an appropriate place, or inappropriate, depending on how you look at it, for you know, the U.S. Army, City of Niagara Falls, the Hooker Chemical Company, to dispose of essentially all their hazardous waste and all the municipal waste. And for you, those of you that were, and I think you all are in the waste class last week, I did mention how I do deal with several sites that have old historical dumps on them, and back, you know, certainly pre-1950s, all of these dump sites were used for a mix of hazardous and municipal waste, so they are quite hazardous. Okay, so yeah, I would encourage you to do some reading on the Love Canal issue. The second lesson we're going to look at is Malvern housing development. Maybe anybody toss a yes in the chat if they've heard of the Malvern housing development in Scarborough, or a no if you have not. Anyone hear of it? Have not. Aaron, that is where he used to do his locate. So most of you have not heard of it. This was a big issue when I was actually in Durham College, going through the 3 years of the environmental course. The issue in Malvern was actually discovered when I was in the first year of the program. And as we were graduating in the third year, 5 of the graduates were actually hired to work at the Malvern Housing Development Remediation project that was undertaken. But essentially what happened there was in the mid-1940s, Radium Luminous Industries burned radioactive materials to recover radium at a farm located southwest of the intersection of Nielsen Road and Shepherd Avenue. The ash was buried at that site and the soil was radioactively contaminated as a result. In the early 1970s, the Malvern housing development was built by the Ontario government. In the 1990s, the radioactive soil was rediscovered on McClure Crescent and McClevin Avenue. The government bought back the affected properties and excavated the soil from 60 of those properties. So this gives you a little bit of a snapshot on what happened at Malvern. A little more information is that back in the 1940s, during World War II, this material was being used on the dials of aircraft so that they would be illuminated at night without the need for light in the cockpit. So the radium that was used, that was the purpose of using it. As it says, the ash was buried at the site, and there it remained until the 1990s. And it was actually some students out of the University of Toronto that had been doing some research and found some information, and they decided to go to the Malvern housing development and just take some radiation readings. And they discovered, as a result of doing that, that a large part of this housing development was contaminated by radioactive soil. So because the housing development was constructed in the 1970s, there was no phase 1 environmental site assessment done that would have picked up this issue. And as a result of that, residential developments were residences were constructed on top of the site, and we ended up in a position where the residents had to be purchased back. Many of the sites residents were demolished, soil was remediated, and the remaining properties were then resold back to the public. So in order to prevent instances of this happening again, we have Ontario Regulation 15304, right? And it is, as it says here, it's comprehensive legislation to ensure that the health of the public is protected when land that was previously used for industrial purposes is redeveloped for residential use. It is important that these rules are followed so that mistakes from the past are not repeated. And these rules are very prescriptive. If you go to Ontario Regulation 153, it will go through the minimum requirements of a phase 1 environmental site assessment, and all those components that they have listed in the regulation must be there in order to get a record of site condition, which then allows for the site to be redeveloped. The regulation uses a phased approach to identify and mitigating the risk to the public. Right, that phase approach is a phase 1 environmental site assessment, followed by a phase 2 environmental site assessment if required, followed by a site-specific risk assessment or site remediation if required. So if we look at the flow chart, phase 1 environmental site assessment is the first undertaking in the process. So a phase one ESA looks at the likelihood of contamination being present at the site. Okay, and if there is, it's identified as an APEC, so an area of potential environmental contamination. If the phase one does not identify any apex, you immediately go out on the no side, and a record of site condition is filed, and the site can be change in land use is allowed, and the site is then redeveloped. Okay, but if the phase one environmental site assessment does identify an APEC, you must move on to the phase two portion. All right, so phase two is conducted, and if contamination is found above ministry standards, if the answer to that is no, so you conduct a phase two, no contaminants are found, you then go back into the same record of site condition stream. But if yes, site contamination is found above ministry standards, either remediation or a site-specific risk assessment must be carried out. So site remediation, if you do site remediation and that site now meets ministry standards, you can go and get yourself a record of site condition. If you do not want to conduct site remediation because the cost is too expensive, you can go immediately to the site-specific risk assessment process. Or if your site remediation does not eliminate all the contaminants at the site, you must go through the site-specific risk assessment. And as part of that process, a certificate of property use is placed on the land title registry for that property, and then you go back through the record of site condition. And the end result is you are able to redevelop this land. So it is a comprehensive piece of legislation. The legislation does contain what the requirements are for a phase one. It does require what the requirements are for a phase two. Does contain the requirements for site remediation and site-specific risk assessment. And all the steps in the regulation must be followed in order to get your record of site condition. Okay, so we're going to do a little bit of clarification of terminology here. You probably noticed here that we're using this term phase one, where we're actually spelling out phase one environmental site assessment. Okay, but we need to clarify our terminology, right? Phase one environmental site assessment. It is used when, in order to change the zoning of site to a more sensitive land use, the property owner must conduct a phase one under Ontario Regulation 15304. So essentially, industry has adopted the term phase one in the reporting, as has the regulation. So if you see a report and it has phase one with number one written out, it was a phase one that was conducted under Ontario Regulation 15304. And here is the requirements for Reg 15304. It's mandatory for certain changes in land use and often requested by upper lower tier municipalities for development approvals. So it says here mandatory for certain changes in land use and often requested. It's been our experience that municipalities will always require it as part of a redevelopment proposal. It's required generally when industrial operations on the property have ceased. So the industrial operations that have been carried out are no longer done there. The building is usually demolished. We have an empty piece of property, and it's going to be redeveloped into a more sensitive land use, such as residential. The results of a phase one carried out under Ontario Regulation 15304 are published publicly and are available for any member of the public to go online and see. All right, and regulation requirements must be followed. Okay, there is no leeway on what must be in a phase one report that is done under Regulation 153. And then to ensure that qualified persons conducting phase ones have followed the regulation, the Ministry of the Environment does have an audit process where they randomly pool records of site condition that have been submitted to the record of site condition registry, and they will make that particular project undergo a full ministry audit to ensure that all steps of the regulation have been followed. So the second term you will see as phase one, right, with the number one in numeral form. It's a voluntary investigation of the environmental condition of a property. Conducting these studies may be a condition of the sale of a property, or for obtaining a mortgage, or for due diligence by a property owner. There's no legal requirements for these phase ones, but they can be conducted using part of all the regulatory requirements or according to the CSA standard, which is standard Z76801, phase one environmental site assessments. So the second column here is the refers to the CSA standard, sometimes used for the transfer of ownership to protect the new owner, obtaining a mortgage loan on a property, or for due diligence purposes. If a property is changing hands from one owner to the other, and a bank is going to provide the financing, or a bank or a mortgage company is going to provide the financing for that transaction, the bank or finance company will insist that a phase one be done so that they can understand what their potential liability is in the event that the purchaser defaults on the mortgage and the bank has to take over the property. So it's usually done it's usually requested by a mortgage company or a finance company. It can also be done as a condition of the sale, especially if there's no financing going to take place, where the potential purchaser wants to know what his potential liability is of this purchase on the site are. These phase ones are done when the industrial or commercial operations are continuing at the site. So there's no change in the operations, just the business in the land has been sold. The results of these phase ones are kept private, so there's no requirement to post these results anywhere, but phase one reports must be provided to purchasers if it's a requirement under the purchase agreement, must be provided to the banks, finance companies, if they are providing financing, right? And consultants may choose to omit sections and modify sections to suit our own purposes. So we're dealing with a standard. We're not dealing with a regulation, right? Regulation, we have to follow the regulation. The standards, we don't have to follow the standards. But what we find is that if a bank or a financing company is requesting the phase one, they will ask us as consultants to provide them with a confirmation that CSA standard Z768 was followed in the performance of the phase one. And if any components were omitted, we have to highlight that in that letter of confirmation. Okay, so those are the two phase ones that you can see. Phase one with it spelled out, phase one with just the Roman numeral. We're going to focus more so here on the phase one. So that is the phase one that's done under Ontario Regulation 15304. So we'll focus more so on that type of phase one in this module. But the main purpose of a phase one ESA is to determine the likelihood that one or more contaminants have affected any land or water on, in, or under the phase one property. Right. So main purpose is to take a really good look at a property and determine has anything occurred on that property or at an adjacent property that could have impacted this, the property under investigation with an environmental contaminant. It's determined by reviewing available information to identify any potential contaminating activity in the phase one study area and identify areas of potential environmental concern on the phase one property. We're going to take a closer look at this phase one study area because phase ones are highly regulated. We are told in the regulation what the phase one study area has to be. If a phase 2 ESA is needed, the phase 1 ESA provides information that can be used as a basis for carrying out a phase 2 ESA. So the phase 1 ESA will identify what the potential contaminants are that can be found at that site, and it will identify particular areas of the site where contaminating activities could have taken place. And then the phase 2 is developed to target those contaminants and the specific areas where the contaminating activities may have taken place. If a risk assessment is required, the phase 1 ESA provides preliminary information about the environmental conditions of the property. Risk assessments are never done strictly based on a phase 1. Risk assessments are done after a phase 2 has been conducted and it has been confirmed that there is contaminants impacting the property, and those contaminants are either going to be left there, or it is not technically or financially feasible to remediate the site. Then you go to a risk assessment. Okay, so we have phase 1, we have phase 2, we have remediation if required, and we have risk assessment if required. Okay, common sources of contamination. The most common sources of contamination identified in phase 1 ESAs are soil and groundwater contamination from leaky underground storage tanks. And this one is a big one. It's amazing how many industrial facilities had historical underground storage tanks associated with them. And pre-1970, it was common practice to just abandon these tanks in place. We still, to this day, remove underground storage tanks that were abandoned in the 1970s and are still full of product or half full of product, because when they were abandoned, the product wasn't that valuable. It was left in the tank. The tank was just abandoned in place. And the issue with that is, as knowledge of that underground storage tank begins to wane at the site and the employees begin to retire, there is no knowledge left at the site of where these tanks were. So the potential presence of underground storage tanks are generally identified through phase 1, which takes a look at historical documentation. Soil and groundwater contamination from chemical spills and handling related to loading, unloading, and outside storage of materials. Soil and groundwater contamination from the operation of an on-site landfill for industrial waste. And I've explained in the other course of how I do deal with sites that have these on-site landfills. Soil and groundwater contamination from the use of contaminated fill material, and operation of dry cleaning equipment, including handling of halogenated solvents. So this one here, soil and groundwater contamination from chemical spills, handling related to loading and unloading and outside storage of materials. Yes, this is a big issue, but we also in many cases see subsurface soils and groundwater contaminated from actual process operations that take place inside of facilities. Soil and groundwater contamination from the use of contaminated fill materials. Many areas of old cities and towns and villages are contaminated with fill materials. Much of downtown Oshawa, many of the sites in downtown Oshawa were backfilled with contaminated fill materials. And essentially how this happened was many of these towns and cities had old industries like foundries that generated a lot of waste materials. Those waste materials were taken from those industries and then they were used to backfill low-lying areas in downtown cores that were being developed so that buildings could be constructed on them. So we often find while we're doing phase 1s and phase 2s the presence of these old historical contaminated fill issues. And I will try to, as we go through this phase one module, I will try to show you some examples of where we have came across this. And of course, the operation of dry cleaning equipment, the handling of halogenated solvents is a big issue in any commercial plaza or industrial operation that has used halogenated solvents, not only for dry cleaning, but in various metal cleaning operations as well. Okay, it's now 11 o'clock, so we're going to take a quick break. You guys have to be back on in 10 minutes for the waste lecture. I'm going to start the waste lecture with just a quick discussion about the recordings of these. I have changed the method of recording these. I'm now recording them online. This is the first lecture, so I'm not sure how long it's going to take for the administrative part of that to occur after I end this session. So if I'm a couple of minutes late getting on to the next one, it's because Zoom has not finished the process of finishing the recording and storing it. So if I am late, maybe just let anyone know that's on there that I may be up a couple of minutes late, and don't just leave the lecture. Okay. All right. So thanks for participating. Yep, doesn't look like there's any questions. I will resolve this issue with you guys not being able to access these documents as soon as possible. So thanks a lot for attending, and I will see at least some of you at the lab tomorrow. Thank you.